Okay, good afternoon, everyone. Welcome to the Let's Talk Energy presentation. Oops, sorry, guys, I got to get back to the top of the slides. My apologies. On integrated energy solutions for data centers. We have a panel of folks that are engaged in the industry and have incredible knowledge about this market and what's going on. And so it's an opportunity for us to engage with yourselves and give you some input and insights on what's happening in our world. First off, I'm going to have a couple of housekeeping items to take care of. The first one to note is that this presentation is provided on a without prejudice basis and does not constitute legal advice, guarantees, offers, or warranties on behalf of Toromont or any of the presenters today. The panelists are offering guidance on possible customer scenarios, but their answers should be used as a general guideline only. Next, you should be aware that this webinar is being recorded, and if you do not wish to be recorded, you may leave the session at any time. Finally, just a proviso that we like to make, be safe, be present, conduct business the right way, and pay attention to cybersecurity. These are fundamentals of Toromont and the Caterpillar world, and this is a tenet that we approach at the beginning of every meeting, and we hope that everybody stays engaged and follows us through the entirety of the presentation. So, this is the panel of presenters. I myself am Ron Cocking. I am the Manager of Strategic Partnerships at Toromont CAT. Working with us today and presenting on a variety of subjects where they have expertise. Shay McMaster, who is the Product Support Manager at Toromont CAT. Jimmy Schutt, Vice President at AVL Enclosures. And Jimmy will have two team members joining him today, Vladimir Jarek and Aurel Karina. Following Jimmy, we will have Scott McLeod. Scott represents the Market Development Manager at Simcoe Refrigeration, our cooling division. We have Mark Piazzesi, who is the Executive Vice President at Quasar Consulting Group, and Anas Youssef, who is the President of Urbicon Data Center Solutions, a customer who is implementing these technologies in the market. And first off today, we have Mark Piazzesi leading off, and Mark is going to talk with us about data center market trends and challenges. And Mark, just to kick it off, I would ask you, what are the biggest challenges you're seeing in the Canadian data center market right now?
Well, thanks, Ron. We're opening up with a bang with that question. If I'm being direct on that one, I would say it's supply chain specifically. The single biggest shift we've had to adapt is procurement sequencing. The old model of design first, then buy doesn't work anymore for major equipment. And we're having conversations about procurement strategy well before projects even start, which has been a significant adjustment just in terms of project delivery and also adjustment for clients who aren't used to committing that sort of capital early. Well, thanks everyone for joining today. For decades, really, data centers evolved relatively predictability. But over the last 24 to 36 months, that pace of change has accelerated dramatically. AI and high-performance computing workloads have fundamentally changed many of the assumptions behind how data centers are planned, powered, cooled, and deployed. And today I'm going to be briefly walking through some of the major shifts that we've been seeing across the industry and how AI infrastructure is reshaping the conversation around data center design. I can go next slide, please, Ron. So historically, most enterprise, oh, sorry, you can go back one. Yeah, this one's fine here. Historically, most enterprise environments were designed around a low density compute. So what that means is rack density in the range of 2 to 5 kilowatts a rack. And from then, we started seeing deployments between 10 to 30 kilowatts a rack, which became fairly common. And AI infrastructure has changed that trajectory very quickly. There's been a huge shift in the rack densities. We're seeing deployments, 130 to 150 kilowatts a rack right now, and even beyond that in some cases, depending on the hardware platform that's selected. So what's been a lot of fun, I would say, is the industry compressed what might normally have taken a decade in terms of change in only a few years. And at these densities, nearly every engineering discipline becomes affected. What's interesting is that the density itself is no longer viewed as an exception. It's increasingly becoming part of the baseline design conversation when we start. I can go next slide, please. So as rack densities increase, the cooling strategy have also evolved rapidly as well. For many years, as many people will know, air cooling was the main approach across most enterprise and hyperscale environments. But AI workloads have pushed those thermal loads beyond what traditional air systems can practically support. And as a result, liquid cooling has moved from being a niche or a specialized solution into a much more mainstream design strategy. Today, we're seeing rapid adoption of technologies like rear-door heat exchangers, direct-to-chip cooling, cooling distribution units, and hybrid cooling environments as well, where both liquid and air systems coexist in the same facilities. A lot of the challenges for cooling are not just mechanical specifically. It now directly influences the architectural planning of the building, electrical coordination, operation procedures, which have all become new, and long-term scalability of these facilities. There's also a much greater emphasis on operational readiness. And because a lot of these deployments are evolving so quickly, the industry is still actively learning and refining best practices in real time. Next slide, please. Another major industry shift has been the growing importance of power availability and utility infrastructure. Historically, discussions around data centers were often around square footages of white space. But today, the first question is often how much power can actually be delivered to the site and by when. And in many regions, we're seeing utility access has become one of the primary drivers behind the site selection and project timelines. Where power is not available, decisions to bring your own power, if I can say that, by using natural gas generation is also been a consideration. At the same time, long lead times for major mechanical electrical equipment have created a lot of pressure across the industry. We're seeing increased interest in prefabrication, scalable power blocks, and design approaches that allow infrastructure to grow incrementally as capacity becomes available. One thing that stands out in this conversation around speed to power is almost as important as speed to market, which has been a big change. And in many cases, utility coordination has become one of the defining factors in whether a project can move forward successfully or not. Next slide, please. One of the other broader trends emerging from all this is that data centers are increasingly beginning to resemble campuses rather than traditional buildings. The scale of electrical demand alone has changed that in many ways. We're now seeing conversations about dedicated substations on the site premise, large-scale utility planning, heat rejection strategies, and even long-term regional energy planning, which is quite intriguing when you're talking to utilities and how it affects in some cases, the province on when you're switching these large loads. There's also growing discussions around heat reuse, renewable integration, and how these facilities interact with the broader grid infrastructure. It's no longer just about a single building or a single deployment. This long-term infrastructure ecosystem that may continue expanding over many years. Despite how quickly the market has evolved, the reality is that the industry is still adapting in many ways. A lot of the standards, operating models, and deployment strategies are still maturing. Manufacturers are evolving their platforms rapidly. Design teams are adapting to changing density assumptions, which in some cases change when you're in the middle of a project, depending on the technology that's being deployed. And I think I've said it a bunch of times and probably a few more, the supply chain pressures continue to affect procurement timelines and the project execution strategies, which is a huge item that everyone's trying to still wrestle with. We can go next slide.
About 1 minute, Mark.
Sure. Okay, so where is the industry heading? Looking ahead, most indicators suggest that the trends will continue accelerating. We'll likely continue seeing higher rack densities. There's the path to the 1 megawatt a rack, increasing liquid cool adoption, and greater emphasis on modular and scalable infrastructure approaches. Prefabrication and speed to deployment will remain important. One big item is flexibility in terms of design, because ultimately the biggest challenge may not be the individual technology, simply the pace of change itself. And the industry compressed what felt like a decade of infrastructure evolution into roughly 3 years. So everyone's still wrapping their head around that. But it's still very early in understanding where the evolution ultimately leads. Thank you.
Thank you, Mark. That was really insightful. Appreciate that input. Next on the agenda, we have Anas Youssef from Urbicon Data Center Solutions, speaking to data center operations, reliability, and resilience. And Anas, what are the most common operational pitfalls you guys are encountering in your data centers now?
So thanks, Ron. And actually, this is a great, Mark teed us up perfectly. So thank you for that, because I think 2 or 3 that we see constantly and big challenges is the first being increasing client demand and just the speed of deployment. So to Mark's point, where we used to see uniform halls of 8 to 12 kilowatts a rack, now we're seeing high density racks in the range of 50, 60 kilowatts in the same room as the low density. So it just, and where it may have taken a client upwards of a year to load a hall significantly, we're now seeing it in multi-megawatt pods that shift the critical environment practically overnight. So that's been something we've definitely had to work closely with our tenants on. Third-party risk is always there. So third-party failures, whether it be equipment failure or a power outage, you're at risk, especially as kind of the operation becomes more complex and tenants have certain demands in terms of maintenance windows, et cetera. So that risk can also increase as maintenance may be deferred or issues and processes aren't documented appropriately. And then finally, the human element is always there. So design and redundancy are not a substitute for process training and the right tool set, really. So organizations we see want to invest heavily in redundant architectures, but then and assume that just brings resilience. But redundancy alone only protects you as to the extent that your failover procedures are tested, your staff knows them cold, your monitoring catches the moment a redundant path degrades. So kind of that operational element and maturity really needs to support the infrastructure. And I think for us, we are a bit unique in that we're purely focused on a single tenant model. So that mitigates, not just manages a lot of these risks for us. So it's one client, it's one set of requirements, one operational relationship. So slightly less complex than a multi-tenant facility. But those are three, I would say, key challenges that we see constantly for operational teams. We can go to the next slide there. And then we kind of, in talking about the design and redundancy, and I think one of the questions that always comes up is how do you balance cost versus redundancy? And we have the privilege of working with hyperscalers whose approach to redundancy is pretty well established. And it only really shifts, we find, depending on certain deployments that might require, N+1 is not going to do it. We're going to go to 2N on that one. But where we do think a great conversation that is had with clients is usually around the return on investment. So where is the where in the redundancy spend can you get the best return? So usually we see that for us, it's about power. So power is typically the highest return on investment. So a properly designed UPS generator architecture that protects you from the most common and most costly failure is usually really key. And then secondary, we see cooling redundancy as a very close second there. And again, I'd like to emphasize, and I know I'm coming from the operator angle, though, that operational resilience alongside the physical redundancy is really, really key. The operational discipline, the monitoring, staff training, those are really necessary in order to support the physical infrastructure. And then systems that can adapt. I think Mark touched on this point. Some of the, how do you design a system today that can continue to grow in the future as a lot of the tenants today they may be deploying 30, 40 kilowatt racks or 50 kilowatt racks, but they're looking to a runway of 150 or more. So how do you do that all within the same facility without locking up too much infrastructure up front and costs getting even more excessive than they currently are? So we work closely with the tenant. We work closely with partners such as CAT and others within the industry in order to understand as much as we can where things are going. None of us have a crystal ball, and we'd all be in a different place if we did, I think. But we've seen that forward-looking approach pay dividends for us. In one of our facilities, or one of our most recent facilities, we were able to take what was a capped limit on per rack densities, quadruple that without having actually to change anything from a operational or infrastructure perspective. So again, trying as much as we can to look forward, and really we benefited from a lot of planning with our tenants in terms of where they saw it going into the future. So that's been a really key element in terms of the actual system design, I'd say. We can switch to the next slide, if you don't mind. Another key element for a resilient operation is data for us. So this is both in current operational data, in post-incident reviews, and then that tenant deployment coordination that is really key for us. So we've been seeing dividends in terms of we've introduced AI into our CMMS, which then kind of is coupled with information that we get from our building management system that provides continuous visibility into power, into cooling, to the environmental parameters, and it enables us to have kind of predictive intervention before a fault becomes a failure. And really, it's those two sources of information allowing us to anticipate things. So anything from a spare parts shortage to a potential failure, through just tracking all incident information. We're tracking things like PM to CM ratios, mean time to repair, mean time before failure, just to try to get ahead of where the trends are going. And it's really that operational data that informs that. And then we try to make operational decisions from that data. So we're trying to contextualize it as much as we can to the site itself, to the geography itself, where, as opposed to, let's say, changing filters on a campaign or on a schedule, we're measuring pressure on that filter in order to make individualized, contextualized decisions as opposed to kind of pre-programming it. So we found that leads to getting ahead of certain issues, and that's been very successful for us. And then just trying to integrate all of that information as much as we can into our training programs, and those training programs are contributed to through our partnerships in the industry and then with the tenant to just try to keep everything as up to date as possible. And mentioned earlier in terms of data as well, just client deployment coordination. So as much as we can, as early as possible, modeling out where they may be going, what they're currently testing today that might roll into a facility in 2 or 3 years, gives us a bit of a look ahead in order to try to decrease risk at the outset as much as possible. You can flip to the next slide if you don't mind. And then lastly, a resilient facility is really as good as its operating procedures. So, we try to maintain a rigorous preventative maintenance program, documented change management processes, regular emergency response drills calibrated to the specific environment and different failure scenarios that we model out. And MOPS. We think MOPS are the key part of any robust operational model. We ensure we're constantly updating them. We're regularly collaborating to make sure they're as sharp as possible. And then we try to limit human error in those as much as possible through digitization. There's very strict authority matrices, robust communication procedures to ensure that not only is the operation sound, but we're really trying to minimize as much as possible any potential for human error. So that it's all about kind of marrying both that operational rigor with the smart design up front. And given that we have dedicated teams, again, it's a bit simpler for us maybe than others in terms of having a dedicated team to a dedicated client. They have that sole accountability of that facility for that procedural requirement that comes in. So we then take all of that, and it's rigorously looked at and reviewed and assessed, not only internally, but we have assessments with our client weekly, monthly, quarterly. They engage third parties that come in and look at everything from a risk perspective and look at all of our operational models, all of our operational procedures. And so we're constantly auditing the process to ensure that we're as up to date and complete as possible. So really marrying process, procedure, and that initial kind of smart design where we try to be as efficient as possible with the dollars spent.
Well, thank you for that, Anas. That really paints a clear picture of the complexity of everything an organization like yours deals with and what it takes to really maintain that level of service for your clients. Appreciate your input. Thank you.
Thank you.
Next, we're going to have Shane McMaster speaking to Power Systems Equipment Lifecycle from the perspective of the service provision at Toromont. So Shane, customers, they represent critical infrastructure and demand high availability. How can these customers ensure that high availability of their sites through the life cycle of the operation?
Great question, Ron, and I'm glad to say that is exactly what I'm going to be covering today. So good afternoon, everybody. Today, I'll be touching on a few items in regard to the serviceability of your critical power systems in the data center market. Mainly the life cycle cost of maintaining your fleet, CAT's extended oil change program, SOS fluid and sampling and why it's beneficial, leveraging technology using Toromont and Caterpillar software and apps, CVAs, which is customer value agreements, additional testing, and lastly, Toromont's world-class service teams. Slide, please. Using planned indicators, we can provide a variety of services to help keep your gensets online and available in case of an emergency. Indicators such as SOS sampling, which I will touch on a little bit later in this presentation. Also monitoring engine hours. Our O&M manual has quite an extensive guideline on what work needs to be completed based on the hours you have accumulated on your gen set to help you maintain uptime, including but not limited to semi and annual inspections, oil changes, load tests, quinquennials, valve sets, and many other items. If you happen to be an end user or a building manager firm, speaking with your building operators and maintenance personnel, they have the most touch points with your assets. And when they're doing their daily, weekly, or monthly inspections, as well as run tests, generally they might be the first ones to know if you're experiencing an issue with your emergency power systems. Monitoring fuel consumption is another good way to tell if something is off. You can always expect some fluctuations in fuel consumption during seasonal changes, whether the weather's hot or cold. But if you notice a big increase from what's normal, it could be a clear indicator your engine's not operating optimally. And also using a site operation maintenance advisor or Toromont condition monitoring, you are able to leverage technology to help predict component life estimates, helping you spot issues early, making the necessary repairs and reducing unplanned downtime. Slide, please. This brings us to our modified PM program. So Caterpillar offers a 2 to 5 year program where you extend the life of your oil. This helps you reduce some waste and the environmental strain due to less fluids being exchanged each visit. Shorten downtime during your annual PM on the non-oil change years, giving your maintenance budget a nice break, especially with fleet sizes ranging between 2 and 100 plus gen sets. There's an opportunity to save almost $50,000 of maintenance cost on fluids alone during the equipment lifespan. Slide, please. SOS fluid sampling is another way Caterpillar and Toromont set themselves apart from the competition. SOS sampling is included with all of our annual service offerings and processed at an in-house lab, which handles in excess of 300,000 samples per year. We use this info collected along with condition monitoring to allow us to spot issues, make recommendations based off the results, once again, minimizing unplanned downtime, meaning your gen sets are ready to back up power when needed. The results are emailed to you, saved in our serial number database, and also stored on VisionLink, one of the best tools available for you and your fleet. Slide, please. VisionLink gives you the ability to manage your assets, CAT and non-CAT, in one central solution, boasting features like excellent fleet visibility and management, all of your data in one location. SOS results, your CAT inspections, as well as health monitoring using our product links, faults, ready to run status, engine hours, fuel consumption, maintenance scheduling, and other user-defined notifications can all be leveraged using this. For a data center application, I would say the number one feature of VisionLink would be the fleet at a glance dashboard, giving you a quick snapshot of all of your connected assets in one convenient location. One notable, there will be a future Let's Talk Energy on this topic later this year, so stay tuned. Slide, please. Along with VisionLink, we have Toromont Digital Services, one of those being Toromont Connect, our mobile app for your fleet service management. Like VisionLink, you can monitor the health of your fleet. You're able to order parts and make service requests all using the app. If you move on to Toromont Hub, it's our customer portal for all of your admin tasks, including invoice management, service contracts, service reports. Your CAT inspects can be found there, all of your equipment data, including parts ordering. Moving on to Toromont Equip, it's our one-stop shop for all of your used equipment needs. Whether it be machines, used product, or restored parts, you can find it there. And a link to parts.cat.com, giving you access to all of your Caterpillar parts needs and their entire database. Slide, please. CVAs. CVAs are our best way to give value back to the customer. These agreements put all of the hassle of worrying about the maintenance of your equipment in the hands of Toromont. Upon registration, our team sets up your agreed maintenance schedule in our system, and our service team is prompted when your service is due, and someone from Toromont will contact you to help plan that in. Or maybe you're a do-it-yourselfer. We have options for that too, as well as where we send you the required parts to get your service done by your trained staff. CVAs also give you the flexibility of a payment cycle. You're able to choose annual, semi, quarterly, monthly, and even pay-as-you-go billing, helping you with maintenance budgets, especially with large fleets. All of our CVAs include one SOS sample of your oil taken per year, allowing Toromont and yourself to monitor the condition of your oil, the health of your engine, especially when you're on the extended oil change program. And one last benefit, all CVAs give you a preferred rate for all future callouts while still under the agreement. Slide, please. Along with all of the standard services we also offer other services such as vibration testing on your CAT equipment. With proper baseline, consistent vibration testing, it is an easy way to spot if something's not working quite right. With elevated readings on certain orders, a good interpreter can predict which component of your engine or generator should be looked at without much invasive troubleshooting. We also have the ability to perform IR scans or infrared scans on most emergency power equipment, whether that be gensets, ATSs, switchgears, as long as all safety precautions could be met. Regular inspections help you find hotspots to help you have them rectified before they become a real problem and lead to a large unplanned downtime. For more information on our additional services, please contact your local service rep. Slide, please. With a vast territory ranging from Newfoundland to Manitoba and all the way up to the Arctic Circle, Toromont has 12 dedicated power systems regional centers and a team of 250 CAT certified technicians. We have the manpower to meet all of your service and maintenance needs. We also offer 24/7 emergency services with some of the quickest response times around, as well as one of the largest fleets or rental fleets in North America for those just-in-case moments. Overall, Toromont is committed to be a leader in the product support market of the critical power space, here to support you every step of the way as the market continues to grow. Thanks, Ron.
Thank you, Shane. Great, valuable input on the importance of a good maintenance protocol and being proactive in your maintenance to ensure high availability of your assets. Next, we're going to go to Scott McLeod at Simcoe Refrigeration. Is going to talk to us about data center cooling. And as you heard earlier, there's some evolution in this space with the density of the racks increasing. So Scott, how is the shift to higher density racks changing cooling requirements?
I think as Mark alluded to, one of the biggest things we're seeing is with the shift to higher densities, what we could normally do with air, it's forced us to move to liquid cooling. So what we could normally grab with on a 5 to 10 kW rack with air, as we have exceeded the 40 to 50 kilowatt per rack threshold, it's made the requirement for liquid cooling a necessity in most cases. Thank you for the question, Ron. And today what I'd like to talk to you all about is the use of natural refrigerants in data centers, specifically the use of R717 or ammonia as we commonly know it in liquid chilling applications. As we all know, ammonia is a highly efficient, sustainable refrigerant, and it can be implemented safely into these applications. Slide. Just a little chat on safety first. Just wanted to call out that, first of all refrigerants available today have some form of safety compliance attached to them. Slide. And what we're seeing available to us in this industry right now, most of the refrigerants available are either an A2L or a B2L refrigerant. A2Ls do support flammability at a low level, whereas B2Ls, while they do support flammability at a low level as well, also have a toxicity factor to them, that being ammonia. But just like to call out that this refrigerant has been safely used and mitigated risks throughout industries across the world, and applications where human occupancy is much greater than what we're talking about here, such as your local arenas. Next slide. We look at risk mitigation. What we look for is self-contained systems. And in these types of systems, the refrigerant is contained within the package, meaning none of the refrigerant exits the boundary of the package or enters the space being cooled. We implement and design low charge systems that are situated external to the building. And then we add in the appropriate safety systems, which includes leak detection, ventilation, alarming, remote monitoring. These systems are always segregated from the facility in the standpoint that access is restricted to trained technicians, trained building personnel. Next slide. Speaking of sustainability metrics, ammonia can help reduce carbon and water usage metrics to help drive buy-in from your communities. Next slide. With ammonia, we can help reduce your carbon and water. We can design these systems to have low water usage, low energy usage, or a hybrid mix of both to get the best of both worlds. Low water, low energy. Next slide. Next. Yeah. Just wanted to show on this slide what we're calling out here is comparing two packages, an R513 on the far right. Beside it is an ammonia package, same capacity. On the far right, you can see power consumption in yellow and water consumption in blue. Both of those are the energy and water consumption in the ammonia package is greatly reduced in those circumstances. If we need to go to full waterless, one thing to note is that the energy penalty, while both the R513 solution or the NH3 solution can achieve this, the energy penalty to go with ammonia is only 1/3 of the penalty we pay when we go to waterless with R513. Next slide. Speaking of lifetime CO2 emissions, we'll note that R717 on the bottom has no scope 1 emissions because it has a GWP of 0. The R123 option does have a small scope 1 impact. And when we compare the two, we can see that the lifetime emissions, the natural refrigerant of R717 outperforms the R1234ZE option. And most of that is based on the indirect impact through energy costs. Next slide. These ammonia systems are highly robust and adaptable as the data center grows, cooling load changes, temperatures can change. We can adapt throughout the lifetime of the data center. Next slide. Shown here an example of a modular package. This is a liquid chiller utilizing adiabatic heat rejection on top, modularized industrial equipment. It's designed for the specific application, whether it be local ambient, leading fluid temperature, which allows us to optimize for peak performance. These are not catalog units that get slotted into every application. Its modular format provides expandability, and it's highly adaptable for future changes throughout the data center. Next slide. Just showing here an example of a water-cooled package. You can see it's all industrial-grade components. We typically see 30+ year life expectancy out of equipment such as this. The compressors are fully serviced, allowing for preemptive maintenance to reduce the chances of failure. If there is a failure, the compressors, again, being fully serviceable, can be repaired, as opposed to the remove and replace scenario that we see with most alternates. Next slide. Energy efficiency. Just want to read out this little statement from my partner here. In a world where PUE is closely scrutinized, ammonia is a structural advantage, not a marginal gain. Why is that? Let's look at the next slide. Ammonia has 5 times the energy density of most alternate refrigerants available to us. And what that means is basically it has more latent heat of vaporization. It can do more cooling work per pound of refrigerant. So when we look at this chart, we can see R717 ammonia compared to many alternates we would see out there, and it's head and shoulders above in its ability to perform. Next slide. When we apply this to a coefficient of performance for an ammonia package, what we've got here is a pressure enthalpy chart. Hopefully some of you are familiar with these. It's an R717 ammonia package at design conditions for a standard, very standard data center application. And it provides a coefficient of performance of 8.9, which is exceptional. Comparing that on the next slide, this is an exact same capacity equipment, only using 1234ZE. We can see that our coefficient of performance is reduced to 6.8. And what that means at the end of the day is that the R1234ZE option will require 31% more energy than the R717 ammonia package to do the exact same amount of cooling. Slide, please. So as it applies to PUE, power usage effectiveness, which we all talk about, what we've applied here is a R1234ZE chilled water system with free cooling. It's shown in red, and the same capacity system using R717 ammonia and free cooling in blue. It's kind of overlaid on the annual ambient temperature fluctuations, and we're providing a weekly average PUE in a local Canadian municipality, delivering 20 degrees Celsius fluid out to the data center. And what we can see here is in the PUE of the 1234E is always higher, worse than the R717 option. Next slide, please. What this means to us in the real world? Well, beyond the obvious of the energy reduction, the impact to reduced energy bills, as we've heard, energy availability is a problem in this industry right now. And we get in situations where we're locked into a maximum amount of power available. In this example, we're showing a 100 megawatt site, one with R1234ZE, one with R717. And what it provides is the ability to take that unused energy for cooling and apply it to what we're there to do. So we can apply, in this application, approximately 4 megawatts more to IT compute that in other scenarios we'd have to apply to cooling. Next slide. Just high-level summary. Ammonia can help with your compliance and can be safely implemented throughout many industries. It contributes to sustainability and can help with stakeholder buy-in. It's built for the long term. It's robust and adaptable as your data center needs change. and it provides the highest energy efficiency and lowest PUE possible with mechanical cooling systems.
Great stuff. Thanks, Scott, for excellent insight on the evolution of cooling in the data center, and what's possible to help these customers with a couple of critical elements in the form of emissions and energy consumption. Thank you for your time.
Thank you, Ron.
Okay, batting cleanup, we have the folks from AVL, Jimmy Schutt, Aurel Karina, and Vladimir Jarek.
Hey, thanks, Ron, and thank everyone else for being here today. As the data center market continues to evolve and scale rapidly, AVL has remained focused on investing in solutions to support our customers through engineering innovation, manufacturing capability, operational execution, and long-term after-sales support. With increasing pressure across industries surrounding deployment schedules, site constraints, scalability, and reliability, our focus has been on developing solutions that help customers reduce risk while maintaining flexibility and speed to execution. Over the past several years, we have continued to expand both our production capabilities and our service organization across North America to better support the growing demands of this market and the customers we serve. Today's presentation will provide a brief overview of our enclosure capabilities, our approach to footprint optimization and design flexibility, as well as the continued growth of our warranty, maintenance, and service support teams. We do really appreciate the opportunity to share a little bit more about AVL today, and with that, I'll hand it over to Aurel and Vlad to finalize our presentation here for you. Thank you.
Thank you, Jimmy. It's a pleasure to speak about AVL and the capabilities that have positioned us as a trusted manufacturing and engineering partner in this energy sector. As you can see on the map, AVL has built a North American footprint of approximately about 595,000 square feet, supporting the facilities, supported by the few facilities here in Hamilton and in Charlotte, and few other locations that help us produce that capacity and deliver some flexibility to meet the customer demands. A key strength, I would say, to AVL is the ability to engineer from the applications up. AVL is not simply a sheet metal bending box firm. It's engineering with more than about 50 in-house engineers across mechanical, electrical, structural, some acoustical. AVL can take the customer specs, develop them into a practical and manufacturable solutions. For the last, I would say, 4 or 5 years, that AVL possesses extensive experience in designing features that are tailored to large hyperscalers, delivering solutions engineered to meet rigorous demands in some critical data center applications. Their performance, thermal management, acoustical control, and delivery are paramount. Next slide, Ron. AVL is well equipped to support high volume production efficiently. Currently, we are holding up to about 50 production slots per month with the large 50-foot enclosure lengths or sizes built for hyperscale data centers and other applications. AVL has also designed enclosures with the genset ranging anywhere from about 250 kilowatts up to 4 megawatts, providing that it can develop a custom and repeat production programs, delivering multiple enclosures of the same design with consistency, speed, and quality. Designs are meant for multiple states, considering the shore power availability, space requirements, maintenance across all the sites, and the site accessibility to perform the maintenance. UL 2200 fuel management systems, SCR integrations, and planning for the future growth, where some sites might be tier 2 right now but need to be tier 4 in the future, can be also a target or something for AVL to help implement and develop. We always try to make sure that we meet the CSA, OBC, NEC, and all the other codes that we work with and are very well familiar with. And with demand, we try to standardize most of the major components in order to pre-build some of the critical aspects like the fuel tanks in order to fit the strict timelines. Next slide, please. AVL exposure to different environments such as Arctic and oil gas applications enabled us to just optimize and offer just right solution for any application. We ensure that these are purpose-built for harsh environments with the focus on robust thermal engineering, structural integrity, and reliable performance where uptime is essential. We are able to design from sub-zero temperatures, remote installations, and other environments where failure is just not an option. In addition, AVL supports the full life cycle of a project, including custom solutions, installation support, and field service coordination to help ensure a proper fit between the engine and the enclosure and all the ship loose parts that are many times with these larger engines shipped to site separately go together. Next slide. So over the nearly 30 years, I would say, AVL has demonstrated the ability to work closely with the end users, general contractors to develop solutions aligned with specific requirements, standards, and project expectations. This collaborative approach allows AVL to translate application needs into practical, manufacturable designs while maintaining the focus on the footprint, airflow, noise, access, and overall system performance. By combining strong engineering capabilities with deep manufacturing expertise, AVL can support highly customized projects early in the design stage, helping to ensure that site implementation, supply chain considerations, and other execution factors do not become obstacles. This makes AVL a reliable partner, not only in delivering enclosure solutions, but also in helping customers achieve designs that are technically sound, operationally efficient, and aligned with the demand of the project. Orel?
Next slide, please. Thank you again. Just to keep going and building on both Jimmy and Vlad's presentation, I'd like to take over here for our service department. Good day, everyone. Thank you again for joining. I'd like to highlight the service and support capabilities that set AVL apart and provide our customers with confidence throughout the entire life cycle of their equipment. I'm going to start with our dedicated field service team. We currently have 10 specialized field service crews on the road. We continued growth plan to support increasing customer demand, operating in both our Hamilton, Ontario, Canada, and our Charlotte, North Carolina, US locations, as Vlad specified previous slides. These locations are strategically positioned to respond quickly across North America, whether it's routine maintenance, emergency services, troubleshooting, or complete site installation. Our teams are ready to mobilize within a 24-hour call-out team, helping maximize downtime and keeping operations running efficiently. Behind these expertise, we have project is a team of more than 60 specialized project managers, engineers, and technicians. Their expertise span both electrical and mechanical disciplines, enabling us to deliver customized solutions tailored to each customer's specific operational requirement. As you saw some of the previous slides there, many footprints that we can bring to light. From design, modifications, to integration support, to commissioning and ongoing technical assistance. Our team ensures projects are executed efficiently and successfully. To build on that, that's our service and our design teams. To build on that, we provide additional peace of mind. We offer extended warranty coverages for up to 5 years, helping customers protect their investments well beyond the standard warranty period. In addition, we also provide multi-tiered maintenance package. You can see there on one of the slides, a flexible maintenance program that shows multiple tiered systems that we can apply to customers' requirement, however they'd like to handle. Maybe some customers enjoy doing some of their own work, and or we can take over and give you full peace of mind. These programs range from routine preventive maintenance to comprehensive service agreements, allowing customers to choose the level of support that best fits their needs while maximizing equipment reliability, performance, and life cycle. In summary, our combination of rapid response field service teams, flexible warranty and maintenance solutions, and extensive technical expertise allow us to deliver more than equipment. We deliver long-term partnership, reliability, and customer success. I want to take this opportunity to thank everybody, and we at AVL look forward to discussing how we can support your operations. I want to thank you for that.
Sorry, Rel. Thanks, Jimmy, Vlad, Rel. Thank you for highlighting, the type of innovation it takes to meet the needs of a rapidly evolving industry that we heard about from the earlier presenters. Great stuff here. I want to thank all the presenters for their time. Mark, Annis, Shane, Scott, Jimmy, Vlad, and Rel. Really appreciate the insight that you guys all brought to the forum today. And what will happen next is we're going to move into the Jeopardy round, and we'll take some questions from the folks online. What I will do is I'm going to end the presentation slide so that I can see the questions as they come into us. Okay. Okay. All right. Let's open it up here. So across everything that was covered today, AI-driven density and power constraints and cooling innovation, what do you see as the single biggest bottleneck in delivering a new data center capacity today? As a general question we'll treat this like Jeopardy. The first person to jump up and raise their hand can answer that one.
I could take that one. Do I have to raise my hand?
Yep. No, you can go.
Oh, okay, good. Sorry, can you just repeat the last part of that question? It was specifically on delivery.
Yeah. What do we see as the biggest single bottleneck in delivering new data center capacity today?
Utility, getting power to site at these big megawatt ranges. Some of the stuff has taken years to get through, and from something that we see is just purely supply chain. The quantities of equipment that is required is wild, and just getting, maybe you filled one order of hundreds of pieces of equipment, and then the next one requires the same thing. So you're competing with all the same people, all the same customers. It's the same pool of vendors, the same pool of contractors. So I think that's something that we see.
Great. Thanks for that, Mark. Yeah. And from the perspective of one of the vendors out there, this market is so demanding and there's so much activity. It is challenging to keep up with everything that's going on. And if it's hitting the manufacturing sector from the perspective of the utilities, again, the volume and the demand of the scale of these centers, is significantly impactful on across the board for everybody. So thank you for that. What's the single most important thing a data center operator should prioritize when it comes to energy solutions?
I would say, Ron, is probably his need for that energy requirement, right? They would have to know their requirements for not only the backup, the N plus, and utilities coming in, or his energy. So I think that would be one of the largest challenges once that data center is established.
Yeah, yeah, and that makes sense, Aurel. Yeah, it's yeah, that's illogical. Okay, thank you for that. Again, a generalized question, but how do we see the data center energy landscape evolving over the next 5 years?
I mean, I can kind of comment quickly on just from an energy procurement perspective. I think there's an interesting angle. Not only are we not finding huge swaths of power like Mark mentioned right now, and I think there's certain investment that's going in that might open up some new capacity in about 4 or 5 years, if not 5 to 6 years. I think what's another interesting angle for all developers within the space is the regulatory environment that seems to be shifting kind of quickly. So I think we still haven't seen regulations that underpin Bill 40 and how the government might get a bit more involved in terms of allocation of power and what those kind of requirements and filters will be. But that will be an interesting, because we've seen it, in the Quebec experience really shut things down for a while, and now they're kind of reopening and rejigging it. But alternative to just the pure supply of it, it's the access to it from a regulatory perspective that might also shift in the next 4 or 5 years.
Great stuff. Thanks, Dennis. And just out of curiosity, and I have a history in what I will call energy provisioning, so prime power, continuous power in the form of CHP. Do you see an evolution in that direction where self-sufficiency becomes more of a practical norm, or is that something as an add-on to more grid resiliency?
I think we're seeing a lot of that south of the border, and usually that might indicate where we might be going in a few years. I think it's definitely a much larger part of the conversation. I think we've been somewhat insulated in our own portfolio just from the fact that we've been pre-planning and we're sitting on a lot of power right now for kind of not only the next site but the site after that. So we haven't engaged with it as directly as others may have, but I do think it's definitely a much larger part of the conversation than it used to ever be.
Great. Thanks, Dennis. So I have a question here from Samir Sabir. Can you highlight your experience regarding how utilities are handling new data center connection applications, particularly how they perform connection impact assessments?
I mean, from our angle, again, I think there is a certain amount of hesitation after June 1st, that deadline regulatory wise. There's a bit more kind of questions, and I think the one change that we're also seeing is historically a lot of hyperscale tenants would not use, let's say, 100% of the power capacity. They want it there, they need it there, but we're not seeing it there. We do see some of the utilities getting a bit more pressure from the regulatory bodies in order to use and not strand as much of the power that's there. But it's definitely a environment where we see a bit more questions, a few more eyeballs on it. So I think it's definitely getting a bit tighter, just given the massive amounts of demand that's coming into the market.
Great. Thanks, Dennis. And one last question today, folks, from Brendan Debnam. Given our current trajectory, do you foresee a critical bottleneck where the availability of high-performance components cannot keep pace with the rapidly escalating power and infrastructure demands of modern data centers? Tough one.
Yeah, I don't know if we have anyone on here that can talk to that, but that's a great question.
Yeah, it's a great question. So what I would say, Brendan, is from the perspective of the OEMs or the representative of an OEM of power generation equipment, Caterpillar recognizes, and there's an example of many vendors out there, recognizes the impact and the influence that this this market is having on everything, and so they have undertaken pathways to try and meet the demand, and it's taking time. I think Mark made a point earlier that the timelines accelerated so quickly on everybody that it was hard to be prepared for it. So looking at the utility infrastructure and availability, what should have taken 10 years was cut down to 3 years, and it's the same thing happening in all of the elements of of the equipment supply, of the critical components. And so Caterpillar is an example, and just using them as an example, Caterpillar has expanded their manufacturing capacity. They have doubled the size of the preeminent factory that produces the most common standby genset for this market. So they had a factory of existence that could create a sizable volume of units. It's doubled, and that came online in 2026. And is growing into full functionality in 2020. 25. It came out on 26. It'll be in full capacity. They are leaning on their factories globally to meet some of the demand, and so other manufacturers and vendors that we work with are in a similar position. Again, because this came on very rapidly. And particularly the load in the US was very, very substantial. These vendors are playing catch up to that volume, and they are doing similar things. The trick of the tail is being able to grow with the market and understand that the market could tail off again at some point in time, and how do you decelerate from that? So there's a lot of conscious thought that has to go into the process of making the decision to double the size of my capacity. Go ahead, Brendan. If you put it in the Q&A, I'll see it. Okay. All right, here's one for our AVL friends. How do modular and prefabricated data center solutions compare with traditional construction in terms of project cost, deployment time? What percentage savings or schedule reductions are typically being achieved today? And do you see modular construction becoming the dominant trend for future data center projects? I guess that's kind of more of a general. Any thoughts?
Yeah, Ron. Basically, I think it ties in well with the requirements of the local jurisdictions where these are, and whatever let's say the fire codes or the building codes are, and that's one of the limiting factor where you can't put as many, let's say, generators into one big space. This is why most of them are built modular. And then a modular, again, it can be also an aspect of we have multiple designs where we do stack together multiple modular designs, one on top of each other or one beside each other, where we're able to almost create a semi-building, if you want to call it that, to be able to kind of help build, because I believe that permits also are a big factor of getting these, and it takes a lot less time to have a modular building and kind of work on it at the same time, rather than getting a big building housed with all the equipment inside.
Great, thanks, Vlad.
If I can build on that, sorry, Ron, if I can build on that, on Vlad's thing there, one of the advantages and pros to a modular build, again, coming from the server side, as we talk, and I'm sure Shane can appreciate this, is when we have a failed component or one of the larger components that need to be serviced, removed, replaced. The modular design gives us a lot easier access to some of the larger components, which again, part of the question was, where's the savings? The savings would be in labor costs, right? If we can disassemble and reassemble pretty quickly, your downtime is minimized.
Well, labor costs as well as downtime, Arel. I think we just went through an experience with an AVL enclosure where we had an engine swap that took place in 2 days. Everything was done and put back together within 2 days. And we had a competitor that had to do the same work, which there was over 2.5 weeks of downtime. Not to mention some of the modular designs our applications team have been working on. Give room to build out power as you need it in the future. You could start off with 5-6 megawatts of power and build up to 18 megawatts as required and as needed later. So lots of good reasons why I think modular should hopefully help footprints and power density in less square footage as we see this market progress.
Great. Thanks for that, guys. And Ellie, I think your question's a little broader than that, but I don't know that we have the right folks on this session to be able to address more modularity beyond the power plant, looking into the facility itself. So that might be a question if you want to follow up with one of the team. We might be able to help you with more information on that. But that's it for all the questions, guys. And I think we'll wrap it up here. We've gone 11 minutes over our allocated time, but really appreciate everyone's time and attention. Great session. Really want to thank the presenters one more time for their time and commitment to putting this together. And just a reminder that we will be hosting our next Let's Talk Energy session in June, and it will cover generator set exhaust and noise emissions, and you will be notified when that is coming up. So thank you everyone for your time today. Have a great balance of your day, and hopefully we'll connect with you down the road.